Right now we're having a presentation by Andreas Schmidt about testing server infrastructure with serverspec. Have fun.
Yes, thank you. Welcome to my talk. Thanks for coming, and thanks also to NETWAYS for having me. During the next 50 minutes, I'd like to shed some light on server infrastructure and how this could be made testable, how testing could be done on it. And well, I think most of you probably heard of the term test-driven development, which is sort of, common sense in the software development industry. No one would seriously go without. And maybe some of you attended the talk of the Jimdo guys this morning. So that you could have seen an example of test-driven development within the configuration management field, like RSpec Puppet and stuff. And yes, I can now link to that talk by looking at the end of the delivery pipeline on the server, how testing can be done there. Testing server infrastructure with serverspec. Some words about me. I work for Cassini Consulting. We're an IT and management consulting company with 6 offices operating in Germany. And I started as a developer in the Java enterprise world, but switched to operations some years ago. And main work topics are infrastructure and deployment automation. When I code, I use Ruby now. I haven't yet managed to jump on the Go train like many DevOps guys do. And that's still something that I need to do. Okay, what I would like to achieve in the next 50 minutes is to introduce some more aspects of infrastructure testing to you, what the purpose of this is, and show to you a tool, serverspec, give you some examples of infrastructure specification and how you run serverspec, and show what it does and how it does what it does, and give a small demo, talk a little bit about use cases and the benefits of that tool. So it's all about provisioning and delivery, and things have gone faster during the last years, whereas some, I don't know, like 5 years ago, you probably ordered new hardware every 3 years and provisioned new servers, and now this has become a task of minutes with virtual infrastructure. And same goes with application installation and delivery, where some time ago maybe you installed an application every 3 months or so. You could now do within minutes, or even latest technologies like Docker. This only takes some microseconds to spawn up new instances. And if things go faster, I want to know, is my application being tested well, so that I can be sure that what I deploy is running correctly and brings business value. And this is most probably true because you have your build chains with tests all over, and if everything's green, then it hops to the next stage. But what about the underlying stuff, the servers? Are my servers being tested well, so that I can rely on certain things to be configured correctly, so that my application that goes on that server have the chance to run correctly? And maybe this is not always the case. Not every company does that, testing servers. And next question would be, if I want to test, then I would need to specify what my server should look like. I would need some sort of specification of how my infrastructure would look like that I can test against. And that question is not that easy to answer, because it might just depend on the type of company you are, or the type of environment you're working in or you're deploying into. And I would like to give some small examples of that. So imagine I would be a startup company, like small team, entrepreneurial, use most recent cloud technologies, AWS and stuff, and make usage of virtual infrastructure provisioning, maybe already do Phoenix server pattern. Like when I want to install a new application, I just throw away my old instance and reproduce a complete new instance because I have my automated provisioning processes in place, like Phoenix server, like the magic bird that just burns down and recreates itself from its ashes. So why do I do this? Because, of course, low cost or lower cost, or using cloud technology, a more direct cost model, only pay for what I need. And of course, the shorter cycle time. I'm just faster with that sort of technology. But maybe I'm not a startup. Maybe I'm in a more classic IT environment, like a company that's been around for longer, corporations. Maybe I have both virtualized and non-virtualized infrastructure and mixed provisioning processes. Maybe I use Phoenix Server for some parts of my infrastructure, but maybe others are install, deploy, provision totally manually. That's still common. And as a classic company, I might make use of outsourcing, like deals where I have hosting providers or housing providers where my hardware sits, and thus I automatically create or need some form of processes to deal with them. And classic environments or companies typically may put more emphasis on IT system and software architecture. So they have a need for at least some form of documentation, mostly for internal purposes. And if you buy infrastructure from somebody else, then you need to do some acceptance tests to make sure that what you get is what you ordered. And we can take this even further with what I would like to call regulated IT environments, for example, banking, insurance companies, or governments. They may not freely choose the hardware they wish to or the processes they want to have. They need to put an extra eye on being compliant to what the regulator forces them to be. And they usually need put an extra eye on security issues. So they need more documentation, not only for internal form, but also for external purposes. Not because they like to produce tons of paper, because the auditor wishes so, they're just mandated to do so. And they need some form of auditing capabilities to prove that what they build adheres to the regulations. And I would like to focus on these things to have more documentation, to allow acceptance testing, to allow auditing on your infrastructure. Now, you might say, well, yeah, I already got automated provisioning processes in place, and I got my configuration management, my Puppet Chef, what have you. And these tools already do the things that I need to have. But I would say that maybe there's some things that are missing. For example, lower level configuration aspects. Not everything is managed in Puppet, but maybe you get processes before your Puppet runs, like somebody is going to kickstart your virtual machine, for example, as one example. There are things such as the VM infrastructure, kernel perimeters, networking, who's going to configure your networking within your machines or within your network infrastructure, or stuff like logical volume management. You might have side effects, even when using tools such as Puppet or Chef. You might still have side effects that your Puppet code doesn't roll out the way you want on the final machine. Or, for example, RPM post-install scripts. They might do things that are not covered in your configuration management code. To me, documentation is also a topic. Yeah, I can read Puppet code, but it is complicated, and it gets more complicated as the DSL evolves, for example. So I still need a specification of my infrastructure, which should be sort of human readable. And I need the testing on the machine itself. So what I would like to have is some form of infrastructure specification that is both machine parsable, so that some sort of software can do something with it, and that it's also human readable, so that I and others who are even not in the operations or developer field can read it and can understand it. And that's where serverspec might come into place. www.serverspec.org, or it's on GitHub, serverspec. It's released under the MIT license and maintained by Goske Miyashita. And well, there are a lot of contributors, many of them from Japan, as you can see from the name. And the following sentence I just stolen from the side above. With serverspec, you can write RSpec tests for checking your servers are configured correctly. Now you might say, oh, RSpec, that's that Ruby stuff, and now I'll have to learn Ruby and learn RSpec, and that's complicated. No, unfortunately, it isn't, because these guys managed to make serverspec real simple to write and understand, and even without coding. And I'd like to give a short example, not delving into the details here, just to give you a feeling of the level of abstraction that you can reach when describing your infrastructure. It's really readable. So it says, describe a package, OpenSSH server, and it should be installed, and a file, sshd config, should be in some mode and should be owned by someone, and there's a service SSH that should be enabled, and so on. So this just to give you an idea of the level of abstraction. We'll see more of that later. I have a short demo, so I can demonstrate all the things that or a lot of things that you can do with it. Now, next slides are about how serverspec is operating. And I've also taken into account not only serverspec, but your development process. Say you got your development box and your configuration management code. May it be Puppet or Chef or Ansible or whatever, it doesn't matter. It's serverspec doesn't care about the solution that you use. You write your code, and ideally you test your code, so you have some sort of configuration management code spec, for example RSpec Puppet or Chef spec, and you test your code locally, meaning that is a local process on your development box, which compiles, for example, say for Puppet, it compiles your Puppet code into a catalog and runs through your specs and ensures that what you have in your spec is reflected in your Puppet code just by comparing it to the catalog. It doesn't roll out your Puppet code on some external machine to see if it really does what it should be, just testing locally. So after that, if it's green, if the test is green, you have a sort of provisioning process to some environment that may be a staging environment or pre-production or integration or production, doesn't matter. And your configuration management tool changes the box state to the desired state that you wish to have. And that's where serverspec might come in. I've painted a spec box, meaning you could have an extra machine where your server specs are residing, and where you can trigger a server spec call. That might be an extra machine, might also be your development box. You might also check locally on the target machine itself. It's all possible. Just for making it easier, I just moved it out a bit. So you have your specification text files on the spec box, and then you test on the servers. Serverspec will connect, for example, by SSH to your target server and query things that you wrote in your spec. Like, say you, from the example before, a package should be installed. Yeah, then serverspec needs to query some package management tool whether a package is installed or not. results are returned, and results are written on the spec box. The provisioning process can occur earlier as well on your development box, say with tools such as Vagrant. You can just spin up a VM and have your provisioner, Puppet provisioner, to modify your local VM. And you can have a testing process here as well. So serverspec is also able to check your local VM by attaching, for example, into Vagrant as a Vagrant provisioner, or even spin up a Docker container which you provided, and doing the checks within that VM or container. So there's a lot of things you can do here. Of course, you can, just as I said before, have your server specs on any box that you wish. Doesn't matter for server spec. How is it installed? Of course, easiest way, game install server spec or bundler as a tool. And all your dependencies automatically come in. But maybe you want to know what the dependencies are, so I just summed them up. There's some basic stuff that server spec needs: diff, LCS, highline, and rake. Some basic stuff. NetSSH as a gem package, of course, to SSH to your target hosts. And you need some RSpec basics, which are 4 gems: RSpec, core, expectations, and mock. And you need the server spec stuff itself. It has been divided into 2 parts. First is spec infra, which is sort of a backend for your infrastructure tests, so that it decouples the resource types and specification from a backend, which is able to connect to a machine or run locally, and which is also able to distinguish between operating systems or even distributions within the same operating system. And it includes some helper files. And the server spec gem, lower right, is the front end with the resource types. Yeah. So that's the packages that you would need. And I would like to give a short demo to you, show you some of the server spec basics, give you an overview of the resource types. I won't manage to cover them all, but the most important ones, and see how they can be extended. I'd like to show you how to use further abstractions and take into account tools such as factor and ohi and facts. Introduce roles. Server can have roles, you know that from Puppet or Chef, and show you how you can build specifications that are environment independent, that could take and put to another environment through the usage of properties. Okay, so for the test setup, I have 2 Vagrant boxes. One spec master, where the specs reside, and 1 node. And I'm already on the spec master, and I have a bunch of precompiled specs that I would like to go through. And we are testing the node. So I can do something like SSH node and get to the machine that I want to test. Of course, this is a dummy host name, but whenever you see node in the specs, you know that is the name of the host that I like to test. So easiest thing to start is by calling serverspec init. Go to an empty directory called serverspec init, and it asks me to select the operating system type, Unix and Windows. And you might think, well, Windows, what the heck? But these guys wrote a Windows PowerShell backend, so you can specify your Windows box. But I go with the British saying, keep calm and like press 1 Unix. I can select a backend type, SSH to some host, or exec locally. Maybe I say exec locally. And then what it did is put me a sort of skeleton here, some directories. and a rig file. Rig file is the glue to the command line starter when I want to run a spec test. That's why the rig file is being used. We don't need to look into that. It's pretty much default. And I have a spec subdirectory. And within that, I have a spec helper, which is some more glue to make this work. But we don't have to code in here. And I have a directory localhost because I selected to run locally. On the other examples, the name of that directory would be, in the examples, node, because I like to SSH to the host called node. And within that directories are spec files. This is an example that the serverspec init binary automatically put here. And the files should have all the name _spec.rb, because that's what the rake file automatically picks up from all of your subdirectories. So that's just to show you how to put a minimum skeleton of server specs to somewhere so that you can start your work. I don't need that. I have some predefined stuff, and I'd like to get into the first one, showing the command stuff, and the upper window I will use for showing the code, and the lower window for just executing that stuff. So what do we have in here? A spec subdirectory, then a node subdirectory. And I have two spec files here. Let's open up the first one. This is probably the most simple form of a specification that you can write. It says describe command, uname, do. It should return standard out Linux. So that's probably the most basic stuff, because you're just tunneling through commands to your target servers, which do something, return some output, and you're able to compare this to a pattern. The other example is, of course, you can use regular expressions. The syntax varies then. It says describe command, uname -a. It says it's not so good readable. Right, no. Color scheme desert. And Vim. Oh, it changed the color scheme. No, I don't know how to disable the colors completely. Syntax off. All right. This for pattern matching varies a little bit. It says its standard out should match Ubuntu. And we can run this. And you can see here it picks up all the files that end with spec.rb. And the points indicate, yeah, it's running, it's finished, real fast. 2 examples, 0 failures. And maybe I just change this to, I don't know what, Red Hat. Run it again. Then it says, here's the F. It says failures, command uname should match Red Hat, but it's standard out. That's the command that it executed, and that's what it returned. And it expected, blah, 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 to match Red Hat, but it didn't, of course. So that's a failure. So let's put that back. And then works again. So this is just said a very easy example, and it doesn't offer any abstraction. You can just tunnel through commands and do arbitrary things, but that's not really what we wish to. We want to have further abstractions at that level, not wanting to push commands, but to describe like packages, services, and stuff. So let's continue to the next examples. I have kernel parameters. 21. module spec. Nee. What was it again? Set? Nee, syntax off, not set, of course. That abstraction here is a resource type called kernel module. And I can describe a kernel module NFS and say it should be loaded. That's another matcher that understands what in the context of kernel module is meant. And going through the spec infra backend, that thing knows how to query kernel modules for Ubuntu using lsmod, and is able to match that stuff to see whether kernel module is installed or not. Let's see, works as well. You see there's 4 dots here, so there should be some more stuff in there. What do we have here? Additional kernel parameters, some variation of the syntax, describe Linux kernel parameters, do context means mostly the same as describe, Linux kernel parameter, kernel OS release. It should not match 2.6, but its value should match 3.2. So I can query arbitrary things from the kernel. Or the second example is about the net IPv4 forward. That's a sort of numerical comparison. It says its value should equal 0. So for example, that IP forwarding is not enabled. Okay, let's go into an example with packages. What do we have here? A package spec. Here it says describe package .get do it should be installed. And you can even formulate this to be checked against some other package manager, such as gem. For example, describe package chef. It should be installed by gem. You can run this as well. Works. So you can see abstraction level using the spec infra backend. It knows what to query on the host, regardless of the distro that you have. It knows how to attach to Yum on Red Hat and to Aptitude on Debian-based systems. Okay, next example is the composition of a service. This includes different things to check. I describe a package OpenSSH client that it should be installed, and an OpenSSH server that it should be installed, and I have a file sshd config which should be only read-writable to root. It should be owned by root, grouped into root. And you can have like content matches. It simply cats the file and search for the regular expressions. Here I've just given in permit empty passwords no, and you can also say it should not match something else, permit empty passwords yes. So both of the checks don't make that much sense, but just to show you that you can have matches and inverses of that. And I describe a service that it should be enabled at boot time, and I describe a process sshd and say it should be running, so that he finds a process which is running. And let's check that. Oh, we had an error there. Let's see that. That was an F, a failure. It says file sshd config should be mode 600. And here it prints the command that it issued to find that out. And somehow it didn't return true, it got false. So that file isn't mode 600. So let's take a look. Why not? SSH config. Oh, it's word readable. That's not what we want. Okay, let's change that quickly and run the spec again. And it does. So you might see that as a form of security check that you can specify. Okay, out of the node. What's next? Users. Just as you know from Puppet, you can specify users that, of course, should exist, should belong to some group, and should have a home directory, and also should have a user ID and a specific group ID and stuff. And I have another example. No, spec node. Oops, was it test user spec? Here, describe group OSDC that it should exist, and an OSDC user that should exist and belong to that group and have a home and stuff. And oops, let's switch to that directory. No. And it fails again. It says failed examples. Group OSDC should exist and does not. OSDC user should exist, does not as well, and doesn't belong to group, and so on. So let's see. Take a look at the host. What's wrong with it? And apparently groups and users don't exist. And I have a small snippet there, which is Puppet code, but as a local apply. So I can take that, and it just creates the group, creates the user, puts it into the group, and assigns a home to it. And let's do this. Whoa. Wrong box. No. Of course, I don't need to be root because I have the sudo in front of it. And create that stuff. And let's check again. Regspec runs through. Okay. Back to the spec master. Okay, same goes with files. We already had examples of that. What you can express with the file resource type, that it should be a file, should be a directory, should have a mode, distinct mode, should be executable, it should contain strings, or its content should match some regular expression. That's what you are able to specify. It should be owned by some user, should be grouped into some group. That's just the regular stuff. But you can also describe mounts. For example, my root file system, describe file / it should be mounted with, okay, what device? Dev mapper precise 64 root, and the type should be ext4. And I should have a /vagrant file system. It should be mounted with the type vbox_sf. Yeah. So let's run this. Works also with mounted NFS volumes. You can specify the IP address of your NFS server that you wish to connect to and describe pretty much everything of the underlying infrastructure. Okay, next example is about factor. If you use Puppet, you know factor, that it gives out a lot of facts from the operating system, and it's extendable with custom facts. And I prepared some examples. This is not within the default server spec, but I added a resource type myself, which is, well, it's not so easy to do, but if you did it once and then you know how to, and then it's fine. I can say describe fact OS family, its value should equal Debian, or fact virtual should equal VirtualBox, or even stuff like describe fact processor count, its value should equal 2. Now that is a string, and I've implemented numeric value so that I could express things like my processor count should be more than 2, but should not be more than 4. Of course, this means that you have sort of extra dependency in your system, because on the node being tested, you need factor, or you need that tool that you implemented as a resource type. For factor, this might be okay because you probably have like Puppet or Chef installed, and then you have factor as well. Imagine OHI. Who of you knows what OHI is? Okay, so maybe to the rest, just short, it's the same, pretty much the same as factor, but with a lot more details. And if we would have a resource type for server spec with OHI, then you could imagine you could query and specify pretty much everything about the machine that you want to test. Okay, just quick demo of the rest. Network specs. Works as well. Let's take a look at this one. Could say something like, describe my interface ETH1. It should have IPv4 address of that. Works super well, but I have a dynamic infrastructure. I don't know the correct or real IP address beforehand when I write my spec. So I would like to express something like, it should have an IPv4 network of this. So I make sure that my interface ETH1 is connected to some form of front-end network, back-end network, or stuff. And I'm also able to describe routing table. We don't have the time to go through all the examples, but quick look at routing table, describe routing table. It should have an entry to a certain destination via this interface and this gateway. Let's test this. It doesn't do. Fails at the routing table, should have an entry, and this is just this thing, so I can go to the node. No, it's always sudo, add the route, run again, and then it's fine. So I'm able to specify the whole network of my virtual machines that I have, including routing and stuff, and speed that there should equal to gig Ethernet and stuff like that. Okay, I implemented the same stuff with LVM because I wanted to express that I have a physical volume, volume group, and a logical volume, and looks like, not going through all of that, but something like describe LVM logical volume precise 64/root, that it should exist, it should be available, like up within LVM. Its size in gigabytes should be more than 10, but its size in gigabytes should not be more than 100. So I'm able to specify my LVM configuration for my hosts. Oh, no. Just quick check of that. Rigs back. Okay, finishes. This goes quite fast. Each point here is a distinct SSH call to your node, because it constructs one command, puts it inside SSH to the node, and gets the result and checks it. So you can imagine if you do not have like 10 specs, but 100, this takes a little bit longer. Fortunately, you can instrument rake to run in parallel with multiple threads. So this just puts some SSH load on your platform. Okay, now imagine you don't really want to specify all that files for each server that you want to test, but you have some notion of roles, like my web server is of course a web server, and it needs special routing for the DMZ, and it does not need an NFS, but my backend database server needs an NFS, but no special routing for the DMZ, for example. And coding a little bit, you're able to specify roles so that you can attach single hosts to some roles. And this is ultimately done in the rake file. Just a small example here. We put up a map. This is the server that we wish to connect, and we have an array of roles. And here I say, okay, my node should be in a base role, in the LVM role, and in role needs database. Of course, you wouldn't hard code this here. Usually that information comes out of some external database, like your PuppetDB or some YAML files or even an LDAP. You wouldn't hard code this, but you still need to query that database and somehow put it here in the rake file so that rake can pick it up and choose the correct roles. And RSpec can pick this up. So I've attached 3 roles to it, and now going to the spec subdirectory, things look a little bit different. Each role has a subdirectory, and these contain the spec files. This is the basic SSH server spec. We've already seen that, and LVM are the LVM specs we've seen. And I've put up another thing, said needs database, and its name is connect-db spec. Another resource type that can use, I describe the host, given an IP address or FQDN, doesn't matter, and say it should be reachable with port 22 and protocol TCP. And then it checks whether this host is reachable from my target node. So that's the roles. Run it again. Oh yeah, that's a failure because this spec is wrong. We've changed that to 600. Okay, don't need to correct that here. But important thing is, yes, you are able to describe roles and put your hosts into roles to make it easier to write specs for a whole platform with different server types. And while looking at that example here, describe hosts with an IP address, you could say, oh, well, yeah, maybe that's the correct IP address for my production environment, but not for my pre-production, and no way for my development. Things are totally different when it comes to IP addresses and host names and stuff, and maybe my development environment is a little bit smaller than my production environment. So we don't want to copy and paste that specifications for different environments. That would be ridiculous, but we can introduce things like properties. For example, I made a properties subdirectory, and it contains just one file, all YAML, and this simple YAML file where I say, okay, I have an access network, 10.0.2.0, and that backend network. And now my specs start to look different. If I go to the spec directory and look at add the spec. I have just one spec. Now it says describe, okay, network fact, ETH0. Its CIDR should equal property, which is a hash map that serverspec injects into your specs. It should equal the property of the access network. And it goes to the YAML file, which it's read before, and just injects the right values into here. Now, using properties, this stuff becomes more readable to, say, outsiders who are new to your environment, your project, because if they read, oh yeah, its CIDR should equal 10.020/24, they might say, oh, what is this for networks? That my DMZ, my backend network? I don't know, but here it says, okay, ETH0 is my access network. So using properties can make stuff more readable and comparable between environments. Okay, that were the demo steps. Let's go back to the slides. Yeah, did all of that. Now the most common objection I hear, oh well, yeah, that's nice, but I got all of that in my monitoring. To me, what you just showed is just plain monitoring, and yeah, that is sort of comparable. I would say that monitoring is about dynamic aspects of my system, like servers being crashed, services not reachable anymore, a disk that ran full, and just like shit hit the fan, and that's the dynamic part of my system. But the spec is more for the static aspects of my system, how my system is built, or how I plan and intend it to build. And monitoring mostly is in some sort of internal form, like your Nagios config. Well, yeah, if you know Nagios, then of course you can read your own config. But in general, this is not really human readable. Plus, you might have special checks which touch like business logic buried in some scripts which call other scripts which itself, and so on and so on. And this not really external form, it's not human readable, whereas the specification is an explicit form that is indeed human readable. You can give that to a like software architect or product manager and can say, whoa, I'm going to build virtual machines for you, and our default is this and that. Is that okay for you and your team? And he is probably going to understand it because it's more human readable. Yeah, so monitoring for keeping your system up and running, and the spec is for building something according to a specification and later prove compliance with it. Some words on additional tools. Comparable tools are RSpec system, which has been retired and is going to be replaced by Beaker RSpec. RSpec system pretty much does the same. SSH to some nodes, execute commands, and checks what it gets back. But it does not offer that rich set of resource types that serverspec does. So I think better off with serverspec when it comes to describing the end product. But there's a sort of a bridge tool, RSpec system serverspec, which I didn't try this out, which should be able to integrate your RSpec system checks into serverspec. Okay. Another thing is the Vagrant serverspec plugin. This is a Vagrant. Yeah, this is a provisioner for Vagrant, so you can have your normal provisioner, like a Puppet provisioner or Chef provisioner, which makes up your box the way it should look like. And then you have the serverspec provisioner, which checks if everything is right, just in one step. So Vagrant up, and it does its whole provisioning process, including the testing afterwards. And the last is a URL just for recommended reading. Vincent Bernard on of course serverspec, and since RSpec is able to return its results as a JSON file, he put up a sort of a reporting tool with a web GUI that emits out a HTML website, so you can see, just like looking at your monitoring tool, oh, there's stuff that's green, that's red, okay, I need to take a look at that. Just recommended reading. Okay, so wrap up. What is it good for? It's of course good for infrastructure quality assurance. You're now able to test the end product before the application is being installed. Regression testing, also a nice thing. After migrations, after your next application release being deployed, after maybe side effects have happened, you can do regression testing if your infrastructure still looks like the way you want it to have. And you can implement such thing as an automated acceptance test. When you buy hardware or provisioned hardware from a hosting company, you don't have to go on the servers manually to see if everything that you ordered is in place. You can do it automatically. Automated acceptance testing. Since server spec specification can be used as security checks, you'll be also able to do automated audit tests. You gain auditing capabilities. So imagine an IT auditor which steps up and says, oh yeah, please have a description of your infrastructure, your servers, how they're being built, and maybe he expects a bunch of paper where he can flip through and just selecting arbitrary pages and asking, oh, is this really the way it's built? Now you can show him a specification that he's also able to read because it's human readable and it's automatically testable. So makes audit a breeze. Yeah, to me, most important aspect is that I'm able to start to work in a test-driven way, even for server infrastructure. I can define my environments beforehand. I can build them according to specification. At the start of it, probably most of everything is red, and I code stuff until it becomes green. And talking about environments such as staging, testing, pre-production, and production, now these things somehow become comparable. Like me having struggled with the differences of environments being not comparable throughout the last years, this is a very nice aspect. Yeah, just work in a test-driven way, even on IT infrastructure. And this is the end of my slides. Thank you very much. Questions? Yes?
I have a question. I have all the information which processes have to run, which files have to exist. All this is already in my Puppet configuration.
Yeah.
Is there a way to use this information, or do I have to define it twice?
You mean like grabbing out the details from your Puppet code and put it into... Well, yeah, one easy way I know is because Puppet writes a Puppet state file on your target machine, and this is just the YAML. It says, oh yeah, I changed like the SSHD config to mode 600, and you can afterwards, after Puppet run has been done, you can take that file and parse this and maybe put this into properties or into specification, but not automatically, not from the Puppet code itself. I don't know, I wouldn't know how. More questions? Yeah. And condition?
Yeah, repeat the question, please.
Question was one test that I've shown included an and condition. And the question was, if I got it correctly, if there is an or condition. I do it.
You've shown.
Yeah.
Like the size of the LVM.
Yeah, and now I got it.
And not bigger as.
Yeah. So the end condition is I described it should be more than this, and it should not be more than that, and that's taken together. No, I don't have an easy answer to that. I don't know how to express an OR condition. No, I would have to think about that a little more. So, I'm sorry. More questions? Yes.
Application.
It's mostly double. Yeah.
Installed, test, Puppet,
Yeah.
do something with a driver.
Yeah.
It says, I will change this.
Same with RSpec Puppet. First, the operations guy writes, okay, it should contain a module, and then goes to the real Puppet code, says, oh, include module. It's pretty much the same if the same guys do this. That makes no sense. I think the benefits here is that, for example, both the operations guys and maybe a system architect, if you have such a role in your company, can sit together, even with product managers, and specify how a server look like. So to me, this is a sort of joint effort, because it doesn't make much sense if only the operations guys write such a spec and then throw it over to the developers, which have to get ready with this.
So that's a common usage. Different people using different tools.
Yeah. At least the work of doing the specification should be a joint effort, so that all of these guys and roles can rely on some things, namely the infrastructure that is provisioned in that way. To me. Further questions? Okay. So the demo is the first URL. It's on GitHub, serverspec playground on my GitHub account. And yeah, if you have further questions, I'm around, and don't hesitate to contact me by mail, by Twitter. Thank you very much.